everyone, welcome to the last lecture of the chapter Light. And before this, we had in total six lectures. And in all those six lectures, what we have discussed is about the reflection, refraction, then refraction through a glass slab. We did have a discussion about the lenses, and I hope now you have understood how does the lenses work exactly. And as I told you in the last class, that lenses would be useful when we will be going for the human eye chapter. In the human eye chapter, what we'll be doing actually, we'll be talking about the when we have a specific kind of defect. Let's say if somebody is suffering from the myopia or hypermetropia. If you don't know them, it's okay. These are the defects, eyes defects. If somebody is having issue in seeing the object which are far away, if somebody is having issue in the seeing the object which are closer to his eyes, so how to correct those defects? So for that we use the glasses, and in those glasses we have the lenses. So now we had a discussion about the lenses, and this lens part, what we have understood is that this lens is basically have two kinds of nature. Either it is converging or it is diverging. So these two kinds of nature were there. Now based on this, today I am going to define a new concept which is called the power of a lens. Because once we know the power of a lens, then accordingly we can use it depending upon how strong is that defect is. So that's how we will be finding out which lens to and what focal length of that particular lens needs to be used. If you have experienced it, I hope you haven't. So if you have a specs, then that optician must have told you a number also, that suppose your power is minus 2.5 or her power is minus 1.2. So what does it refer to? What does it mean? All right. So that is basically the power he is telling you. Yeah. Okay. And what is that minus sign is referring to? What is that plus sign is referring to? So that entire thing we'll be able to understand once we know the basics of the lenses. So I hope now we have the clarity about it, and we can begin the session with the power of a lenses, which is a new concept. So what is the power of a lens? Let's see. Okay. So in today's class, mainly power of a lens, combination of lenses will combine them, and at the same time mirrors and lenses combination. So that would be the basically just the numerical portion which I'm going to discuss with you in today's class. All right. So now let us begin first of all with the power of a lens. Okay. So let's begin. So power of a lens means what? So power of a lens is defined as reciprocal of focal length, right? Okay, let us understand in a more detailed way. Suppose if I give you one convex lens, let's say that's my convex lens. Okay, and now here, as you can see, in this convex lens, I will bring the parallel light rays. And what does the convex lens does? It converges the light rays. So let's say this is the principal axis. Okay, and now this convex lens is going to converge them. So the degree of convergence, how strongly it would converge, that's what we call the focal length. Okay, so that's what we define the power of a lens. So suppose in this case the light rays are coming parallel, and after this it will converge at this place. This distance is basically focal length, small f. Okay, here also one more thing. If this is focal length f, so basically this light ray was coming like this, so it was going straight, and now by this angle it has basically diverged. If I show this by the symbol delta, so angle of deviation is delta here. So it was coming straight like this, and now it has become diverged, it converged like this. So this angle which you can see here, this one, that is called the angle of deviation. Okay, so if more is the angle of deviation, which means that the convergence is more, and if less is the angle of deviation, so how would this light ray would look like? If less is the angle of deviation, it would be very less. So focal length would be far away. So it would go like this. And if it is a very high angle of deviation, then it would be converging here itself. If you compare all these three situations, either it is converging here, or it is converging here, or it is converging here. So in the first case, it was the highest converging power it had. And in the third case, it has the least converging power. So actually, if you see what is happening, then power is coming from the inverse of focal length. So if less is the focal length for a lens, the converging power is more. And if more is the focal length for a lens, the converging power is less. So that's what the meaning of power of a lens means, right? So it basically defines the convergence. Or if I talk about the diverging lens, then in that case it would talk about the divergence power. So let's say that's a concave lens, and here we can see first of all that light rays are coming straight, and now they would diverge like this. So this is called the angle of deviation. So now how much divergence it is producing, right? Like how much by degree, how much by angle it is producing the divergence. That is called the it's basically power. Okay. Okay. Now let us remember just the formula that is important, that power is equal to 1 over f. Okay. That's what we need to remember. Now let us begin and talk about the combination of lenses. So where it is useful, let's say suppose you have you go to an optician, and let's say your power is 2.5. Okay, but the optician 2.5 diopter. Oh yeah, I forgot to tell you about the power unit also. I'm sorry for that. The power unit would be that simple. It's 1 by f. So focal length is in meter. So I would simply say that power unit will be meter inverse. Now this meter inverse is also known as diopter. Yeah. So meter inverse, or simply we can call it diopter. So capital D is a symbol, it's not a small d. You should be careful about it. Otherwise, you can simply write 1 over meter. But usually you will find that the lens's power is written in the diopters only. Okay. Now let's go ahead with the combination of lenses. So what does this combination of lenses means? So suppose if somebody needs 2.5 diopter power, but right now in my shop, let's say I have 1.25, I have a zero point 0.5 diopter, and I have, yeah, only these two diopters are available. So these two lenses are available in my shop right now. I do not have 2.5 directly. So what I can do, I can have the combination of these lenses. So I have multiple lenses of this power, I have multiple lenses of this power. So what I can do, guys, I can take, let's call this as lens B, this is lens A. So what I can do, I can take 5 lenses of B type. So how is this possible? This would be equal to 2.5 diopters only. How is this possible? I'll tell you just now. If you do not want to do that, you can use the 2 lenses of A type, which is having a power 1.25. The addition would give you 2.5 only. It's a normal simple addition. I'll tell you just now how it is happening and why is this possible. Or somebody can use this combination also. 2 lenses of A, yeah, sorry, 1 lens of A and 2 lenses of B. That can also be done. So in this way, there are multiple possibilities with which we can go. Yes, I think this will not be possible. Yeah, this will not be possible because it is 1.25. Okay, yeah, exactly. So that is not possible. But these two combinations are possible. So actually, what is the main goal here? That we have to maintain the total power 2.5 diopter. So that can be done with the multiple ways. So it is not necessary that you would have 2.5 diopter and then only you will be getting the raise the final that the focal length 2.5 diopter. No, with the help of smaller one also you can make the bigger one. Okay, so like as you can see here, we have 2 lenses here, and both these 2 lenses on combining giving a certain effect. That's a common effect. Let me explain you how is this possible and how is this happening actually. So let's have a look. Let's say I am using multiple lenses. One lens I'm using of this type, then second lens I'm using of this type, placed very near to each other, not much separation. Then third lens is this. Let's say the first one has focal length f1, second one has a f2, third one has f3. And here we have kept the object. So this distance is taken as to be u. Now guys, what will happen actually? The light ray would start from the object O, all right, and it will hit the lenses and it will refract, and it will again refract, it will again refract. So if you see carefully, then this O will act like an object for the lens number 1. This is your lens number 2 and this is your lens number 3. So first of all, if I write for the lens number 1, what I would say, 1 by V1 minus 1 by U is equal to 1 by F1. So that's the equation for the lens number 1. 1 by V minus 1 by U is equal to 1 by F. Now for the lens number 2, what I can say, for lens number 2 guys, this final image formed by the lens number 1 will act like an object, because for this guy, second one, whatever is converged by him, the lens number 1, that will be given, right? So for the second lens, now these things will act like a incident ray. So for second lens, this V1 will act like an object. So this will form an image at V2, and object is V1 is equal to 1 by F2. Similarly, you can write for lens number 3 also. I have just taken 1 or 2 lenses. You can take multiple lenses also. 1 by V3. So let's say the final image is coming at V. So let me just write it with V only. Yeah. So 1 by V, and object will be 1 by V2 here. One by V2 is the object, and that's equal to 1 by F3. So for third lens, whatever is the image formed by the lens number 2, that would act like an object for third one. All right. So it would be coming like this way, and then it will again converge. So accordingly, the image will be formed. So actually what I would say, these 3 equations you will be obtaining. If you write down more number of lenses, you will have more equations. Let's do one thing. Let's add all these equations. Let's add up all these equations. So when we'll add all these equations, what is coming on the right hand side? 1 by F1 plus 1 by F2 plus 1 over F3. And let's look at the left hand side. See, 1 by V1, I have to add this, I have to add this. The moment I add this, what will happen? Cancel. This will also get cancelled. So in the end, what I'll be getting, 1 by V minus 1 by U. That is the only thing which we'll be remaining with. Okay. So now let's see everything in a nutshell. So what is happening actually? The object was kept at a distance U, and final image, that's the final image V, because it is formed by the third lens. So that's the final image. Let's say somewhere here we are getting, and image we are getting at V. So can't we say that we can assume this entire thing as one single lens? Let's assume this entire thing as one single lens, or you can say it's a equivalent lens, equivalent of all 3. So that's the equivalent of all 3. And that equivalent lens, let me just write it here. This is that equivalent lens. For this equivalent lens, the focus object is at kept this location, and image formed by this equivalent lens is V, and focal length is this. So that's 1 by F equivalent. So that's the 1 by F equivalent value. So basically what I'm saying, I can simply replace it with a single lens whose 1 by f equivalent is 1 by f1 plus 1 by f2 plus 1 by f3. So it's that simple actually. Now the point is, like, this f1, f2, f3, these all are the focal lengths. All right. And this 1 by f1, 1 by f2, 1 by f3, addition of all three is giving the 1 by f equivalent for the entire combination. So we can treat the entire thing as a single lens whose object is kept at u and final image is being formed at b. So for you, actually, what is happening? If you are the observer, you would just say that object was kept there and the image is being formed there. Now it doesn't matter for you who has done this. So for you, it is like a single lens whose focal length is 1 by f1 plus 1 by f2 plus 1 by f3. That's it. Now, similarly, what I can say, 1 by f equivalent is like a equivalent power is equal to P1, because 1 by F1 is P1, and so on. Okay, so that's it. So that's what I wanted to tell you in the topic of combination of lenses. So in the combination of lenses, what did we see in the end? That 1 by F equivalent is equal to 1 by F1 plus 1 by F2 plus 1 by F3. And also at the same time, we saw that equivalent power was equal to P1 plus P2 plus P3. Okay, that's it. Perfect. So that's what we call the combination of lenses. Now let us go ahead with one numerical and let us see how to use it. So if you get a question like this, then now you don't need to get scared from it. Suppose one lens is given, focal length 20 centimeter. It will be positive. Then a concave lens is kept, focal length, let's say minus 40 centimeter. Okay, some simple values I'm taking. So actually, guys, in the paper, they won't tell you whether it is minus or plus. That's what you have to decide. So here I'm just framing the question myself. So I'm writing here minus 40. Otherwise, in the exam, if they give you that focal length of a convex lens is 40 centimeter, it does not mean that you will take it plus 40. You have to take it minus 40 because that's a concave lens. So it's diverging in the nature. Okay. Now let us take the object at this place. Let us take the object at this place. And let's say the object is 100 centimeter away from here. I'm trying to take some simple values. So the question is find out the image, find out the image location. That's the question. Okay, let's do the question one by step. If you are okay, you can do this yourself, right? It's not a very big tough question. See, first of all, I can simply write down 1 by v minus 1 by u is equal to 1 by f equivalent. And lenses are kept very close to each other, so I can use 1 by f equivalent is equal to 1 by f1 plus 1 by f2. So now what I would say, I would just write 1 by 20, and this I would write 1 is 1 by 40. And I can take 40 LCM. So this will become 2 minus 1. Yeah, 2 minus 1. So 1 by 40. So equivalent focal length is coming out to be how much? It's coming out to be 40 centimeter. Okay. That's the total focal length of the entire combination. All right. So we can just check the calculations here. 1 by 20 minus 1 by 40. And we can take the 1 by 20 common from here. Yeah. So 1 minus 1 by 2. That's giving us 1 by 40. All right. So if you see one thing, notice one point thing here, that overall focal length in the end we are getting is plus 40, which means that it's a combination would act like a convex lens. Yeah. So now some people get confused when I say this. Let's say focal length for concave was more and so it should overall it should act like a concave lens. So guys, focal length doesn't matter. What matters is the power. So for the convex lens, the power is more because the power is inverse ratio. So for convex lens, the power is more. If the power is more, then that would dominate. Okay. So that's how we'll be dealing with it. Now let us begin. So now let me use it. 1 by V. Object distance I must take as minus 100. Sign convention is equal to 1 by equivalent focal length is 1 by 40. So 1 by V plus 1 over 100 is equal to 1 by 40. Now what I would say that it will become what? 1 by V is equal to 1 by 40 minus 1 by 100. So I can take the 4000 LCM. Yeah, that's what I do. And simply I can write 60. So 0 and 0 will get cancelled out. So V will become how much? 400 over 6. Just see if I have done everything correct. Yeah, seems everything to be correct. So 200 over 3 centimeter. So final image is being formed 200 over 3 centimeter from here. Okay. So that is the final answer. Image will be formed at 203 centimeter. That's all. Okay. So that's how we deal with the questions of such type. Now, let me begin with the mirrors and lenses. Now, when we talk about the mirrors and lenses, then mainly I'll be dealing with the question only, right? So the first part here is the question, because mirrors and lenses means what in this topic. What I'm going to do is I'm going to take one mirror as well as one lens, and I'm going to combine them, right? So let's say we'll use one mirror, we'll use one lens, and then in the end we'll have to answer where will be the final image being formed. So let's see if I have a space on the next page. Yeah, we have enough space here. Yeah. Okay. So we can use that part also. So here in this question, let's see how to deal with such questions. But first of all, I would recommend you to solve this question yourself. If you're able to do it, very good. It's nothing new. It's everything is the same thing, like the same way as we have done earlier, that we'll be using the mirror formula, we'll be using the lens formula, and then in the end, final image which will be formed, that is our answer. And always remember one thing, object, original object will be sending its rays on the lens or mirror, whatever is kept first, and then that would do its job, and then later on we will get the reflection or refraction, whatever is kept next from that. Okay, so let us read the question. A convex lens of focal length 20 centimeter is placed coaxially, means the same axis, with a convex mirror, radius of curvature 20 centimeter. So this is the information for convex lens, and that's the information for convex mirror. Axes are same. The two are kept at 15 centimeter apart from each other. A point object lies 60 centimeter in front of the convex lens. Okay, so first is the convex lens. Determine the nature and position of image formed. So let us just draw the figure just for clarity. Yeah, so that's the convex lens, and here we have the object. How did I know that which I have to keep first? Because it was said in the question that object is placed 60 centimeter in front of the convex lens. So first it will deal with the convex lens, and that's the principal axis which is common for them. Coaxial means co means same axis. So coaxial. Okay. So what will happen, guys? First of all, this will act like an object. Okay, it is an object only. So 60 centimeter distance from here. So let's see how we'll work for the lens. 1 by V minus 1 by U is equal to 1 by F. Because that's what we have done in the previous cases also. The lens formula. So 1 by V minus object distance will be taken as minus 60 is equal to focal length of the lens 20, and that too in positive because it's a convex lens. Now I would just write 1 by V is equal to 1 by 20 minus 1 by 60, because that's plus 1 by 60, so that we can take on the right hand side, it will become minus 1 by 60. So now I can take 1 by 20 common, and this will become 1 minus 1 over 3, which is 2 over 3. Right. So this will become 30 centimeters. So from here we will get V is equal to 30 centimeter. So that's the place where the image is being formed. Let me write it somewhere else, because I'll draw the ray diagram also. I'll try to do that so that you understand it very well. So V is equal to how much? 30 centimeter, right? Yeah. Do not forget to inverse, because that's a common mistake we make. Now the next is, if this image is being formed at 30 centimeters, so let us just draw the rough diagram. Image is coming real, so that's the incident light rays going this way, and now it is supposed to converge at 30, but guys, see carefully, that itself is only 15. So actually the light rays would go like this, but in between that only they would encounter a mirror. So actually they were supposed to converge at this place. That's what they wanted. But what has happened is, actually because of the mirror, they would get reflected back like this. And finally, what I would say, that they would form a virtual image which will be intersecting virtually at this place. So that's what I am giving you the idea, that image will be formed behind the mirror. So ultimately the nature of the image will be virtual only. It will be a virtual image. Now what's the position? So for that I need to take the object distance. So for convex mirror, it's a virtual object now, because this will act like an object. This image will act like an object for mirror, because what mirror is getting? Mirror is not getting the rays from here. Mirror is getting these rays. So these rays would act like an object for him. So where is the object? Right side 15, because total was 30. From this place, total was 30. This is 30 centimeter. This is 15 centimeter. So the remaining one will be 15 centimeter. So for the mirror, what I would say, U is equal to plus 15. Why plus 15? Because on the right hand side. V we have to calculate. Focal length, I know, yeah, it is how much? So focal length is 10 centimeter, because radius of curvature is 20. So now what I would say, I will just write 1 by V plus 1 by U, because it is a mirror. Do not forget the mirror. It's a plus sign there. And magnification, there is a minus sign. So always remember these formulas. It's a very common confusion. Now 1 by V we have to calculate, and U will be equal to how much? It is equal to plus 15. So let me just write the number here, is equal to 1 over focal length, which is again how much? 10. So let us just solve it. 1 by V is equal to 1 by 10 minus 1 by 15. Now what we'll be getting? 5 over 150, which is, this will be giving us V is equal to 30 centimeter. Do not get confused. This V and this V was different. If you want, I can take this as V1, the final image. Yeah, so do not get confused. So this we are getting as 30 centimeter. So actually the final image is not formed, is formed on the right hand side. That's why we are getting the plus sign, 30. So what is the final location? It's 30 centimeter towards the right side of the convex mirror, and the nature is virtual. So that's how every time we'll have to deal with the combination of mirrors and lenses. So it's the same thing. They could have kept one concave, they could have kept one concave lens and concave mirror. Any combination can be framed, and that's the basic idea I have told you to solve the problems, because in Olympiad exam they would ask you the question from this kind of topics. And in JEE also and medical also examinations, these topics are very common. Combinations of lenses and mirror. Okay, now let's go ahead with the last question of the day. Find the focal length of the lens whose power is minus 2 diopter. Very simple. Focal length is nothing but 1 upon power. because power is equal to 1 over focal length. So focal length is equal to 1 over power. So what I can say simply, guys, is that focal length is equal to 1 over minus 2, which would give you minus 0.5 meters. So that's the focal length. If that is the focal length, what does it mean? It's a concave lens, because focal length is coming out to be negative, which means it's a concave lens. That's it. So guys, that's the end of the chapter, and I hope you have learned something new in the grade 10. I guess it is totally new for you people. The mirrors equation, then refraction you have got very nice understanding in the classes. Then glass lab was completely new for you people. Then you also had a discussion about the lenses, then focal length of a lens, power of a lens, combination of lenses, and then combination. Then we did one numerical based on the mirror and the lens for combination. So guys, I hope you have understood all the lectures. If you haven't understood anything, if you have any confusion in something, what you should do, you must write on the PDF. And now I guess you should solve all the questions from NCRT. If you have left something from there, and anything if you left from the module, you must do that first. All right. And if any question you get stuck, just put it over the PDF, or otherwise you can contact me. So thank you so much, guys. Bye bye. All the best.